In this, we are going to discuss about object-oriented design to implementation. So in that, we are going to discuss about the state chart diagrams which are used for the implementation. In object-oriented design to implementation, first we are having the state chart activity diagrams that already we have discussed in the previous video. So then the second diagram which will be used for the implementation is state chart diagrams. State chart diagrams model the dynamic aspects of the system and which is used to model the life cycle of the object from the time it is created until the object is destroyed. So the major differences between the state chart diagrams and the activity diagrams are state chart diagrams are based on states, whereas the activity diagrams are based on activities. State chart diagrams model the states of an object's lifetime, but activity diagrams model the sequence of activities in a process or an operation. The transition causes an object to move from one state to another state. For example, consider a faculty member in the university. If a person is in the relationship with the university, then the status of the person is employed. Otherwise, the person may be expelled or retired from the university. And then we are going to discuss about the states and state transitions in the state chart diagrams. A state is one of the conditions that an object may satisfy during its lifetime. In the given state, the object may perform some activity or wait for some event to happen. The state of the object may be determined by one of the possible values of the attributes of the class. For example, in the LMS, an object of book class may be open for issue to a member or closed for issue, the book cannot be issued. The state depends upon the actual return date of the book. So the state transition notation will be the rounded rectangle as shown in figure 7.11. The state can also be identified by looking at the links between the objects. For example, a faculty member may be teaching or on leave. This depends upon the link between the faculty and course classes and multiplicity specified between the objects of these classes. And in another example, the sequence diagram for each use case may be revealed the object states. Again, in the library management system, the book is initialized, that is added, or open for issue, that is members can get the book, closed for issue, that is book is already issued, and expired, that is not in physical condition to be issued. State transitions represent the change of an object from one state to another state. The state may consist of entry action, do activity, and exit action. Entry action takes place when the object enters a given state. The do activity specifies the task or activities that must be performed while in the current state and continues until the state is exited. For example, in figure 7.12, that is representing the state with entry and exit actions. The possible states are entry or action, do or activity, or exit or action. So every state chart diagram consisting of two special states, that is start state and the stop state. The next one is the event, action, and God act condition. A state transition may be associated with an event, action, or God condition as shown in figure 7.13. 7.13, which is explaining the state transition details, that is state 1 to state 2, there is an event occur or an action will be done. So based upon this event or an action, in the system, state 1 will be moved from that position to state 2. An event is a message that is sent from one object to another object. An event can be shown using the operation name on the state transition. The operation may consist of arguments. The operation may be a message from some other object. Example, library staff request issue of book. The event moves the book from open for issue state to close for issue state as shown in figure 7.14. Here the issue book operation is associated with the state. So in this 7.14, the event for issue of book is given. So we have two states, that is initially open for an issue. The issue book is, that is with the help of the member barcode ID and a book barcode ID, it will be issued to the any of the member. And then that once it is open and the book will be issued, then it is closed for an issue. the meaning that it cannot be issued for the other members. An action is a behavior that occurs in response to a state transition. The actions become the operation of the object. All actions are non-interruptible and are shown along with a state transition after the event name is separated by slash. Example, when transitioning from the open for issue state to the close for issue state, the action update issue state occurs as shown in figure 7.15. So that already we have discussed earlier. A God condition is a Boolean expression that tests whether the condition is true or not. For example, the book will be issued to a member if the number of already issued books doesn't cross the maximum limit of the book that can be issued. The next is modeling life cycle of an object. The primary use of the state chart diagram is to model the life cycle of an object and also to model states through which a single object goes through during its life cycle, and also used to model states of an object, and also the state chart diagrams is to model the dynamic object. When a dynamic object is modeled, three things are specified: the states through which the object goes, the events that are triggered for transition from one state to another state, and the actions that are performed during the transition of the state. The process involves the life cycle of the object from the time it is created to the time it is destroyed. In figure 7.16, the life cycle of an object of a book class, we are initializing it and it is open for an issue, that is add book or save the details. Then it is closed for an issue. So once it is open, that is issue book of member barcode ID and book barcode ID code, which is required, and also we can able to update the status. So then after the close state, either the book will be returned to the library by the member, or it is going to be expired. So this is the entire life cycle of an object of a book class. And the next one is creating substates. Substates are nested states or nested inside another states. The outer state is referred to as a superstate. A simple state has no substate, whereas a superstate is composed of two or more nested states. For example, a printer in its startup state might be both heating and initializing. The starting up is a superstate and heating and initializing may be two substates. The superstate reduces the complexity of the state transition diagram. The substates are simply shown inside the superstates and may be nested up to any level. Then example, consider an ATM system. It consists of three basic states, that is idle when no customer transactions are being carried out, processing when a customer transaction is being executed, and switched off when the ATM is either out of service or switched off due to maintenance purposes. Well, the state ATM system is processing, the following steps will be followed: reading information from the card, validation of customer card and PIN, customer selects transaction, processing of transaction selected by the customer, printing of receipt of the desired transaction. If the customer wants to continue with another transaction, then the flow returns to step 3, ejecting the customer. So the state transition diagram of the ATM system with the substates are given in that figure 7.17. So initially it is of idle state, and then we are inserting card. Then processing will be started. Process, that is reading the card, validating the card, selecting for transaction, and if it is not proper insertion or if any error, then the transaction is aborted or cancelled. And after selecting the transaction, then performing the transaction, then we'll print the receipt. If after printing it, if the customer wants to continue, then again he can select another transaction. Then we'll eject the card. Then after that, it will be switched off. That is, it is not available. And the next topic is storing persistent data in a database. As the persistent object survive, even after the program is no longer in execution, There is a need to store these objects permanently in the secondary memory. DBMS is often required to handle persistent objects. DBMS features are efficient storage of data, data independence, integrity and security, concurrency control and recovery, then easy query. The DBMS is used in most of the applications and usually it is specified in documents, which is produced during the requirement analysis phase of a software development.